Question number 3, assignment 2. Now let's try to solve this problem. This problem belongs to Cotter joint. A Cotter joint is subjected to load of 60 kN. All the parts are made from same materials. Safe stress 60 megapascal in tension. So let me write over here 60 in tension. Then 40 in shear. 40 megapascal in shear. Then 100 in crushing. 100 megapascal in crushing. Okay. Now determine the following dimensions of Cotter joint. One is spigot diameter. Then the second is spigot collar diameter. And lastly, the spigot collar thickness. Okay. So let's try the first one. Cotter joint is subjected to tensile load. And in case of spigot side end, the weakest portion is slot side. Okay. Just recall the figures. We have like this kind of figure. Okay. And there is a slot over here, right? So this section, this cut section is weakest sections, right? If we draw from the front, it would be look like this, right? So this is diameter D1 and this is thickness T. So in first question, we have to find out the spigot diameter D1. Okay. So considering tensile failure of spigot at slot. Okay. So we can write like this: load is equal to area. Okay. In our case, area is the complete solid circular shape by D1 square. Okay. Then we are going to subtract the area, this rectangle area, right? So which is D1 into T. Okay. So multiply by sigma T. Now here, because two variables are unknown to us, so we have to take a relations. So generally the outside diameter, or you can say the spigot diameter, is taken as 4 times its thickness. Okay. So you can write like this, D1 by 4 as well. Okay. So let's replace the value. So P value is given 60 kilonewton. So 60,000 pi by 4 D1 square minus D1. Then let's liberate the T by D1 by 4. Okay. And the tensile stress is 60. Now let's cancel out this 60. So simply 1000. Okay. So let's try to take the common value of D1 square. So D1 square, D1 by 4. Here we have pi value. All right. So D1 square by 4, 3.14 minus 1 by 4. So let's find out D1 value, 3.14. So let me take the square root of this. So it's going to be 37.20. So approximately the value of diameter is 38 millimeter. Okay. So fourth part of it, or 1/4 of it, is thickness. So 38 divided by 4 is 9.5. So it is 9.5 millimeter. Okay. Now same cross section, same slot is also subjected to compressive stresses because of assembly of this Cotter with the spigot end. Okay. So just try to remember, when you apply a pulling load or tensile load, definitely because of the spigot actions or socket end, this Cotter is going to strike against these portions, right? So here these two portions are having compressions, right? So let's try to check the compressive stresses over here. Okay. So verifying slot dimension in crushing, right? So this is the area and this is the area where the compression going to happen, right? So same load is acting P is equal to area d1 into T into compressive stress. Okay, so let's verify. Let's find the compressive stress. Now the load is given 60,000. Now diameter is 38 and the thickness is come out to be 9.5. So it comes out to be, the induced compressive stress comes out to be 16620 megapascal. Now this value is something more than the given value. Okay, that is 100. Okay, so you can say it is more than the permissible value of 100 megapascal. Hence this section is getting fail in compressions, right? So we cannot continue with these dimensions. So we have to either increase these dimensions, or we have to use this compression equation to find the dimension of d1 and t. Okay, so let's go for that one. Okay, so let's use the same equations, d1 into t into sigma c. So from this equation we are going to find this dimension again. Okay, so 60,000 here, d1 we are going to replace the value of t, and the value of permissible value of compressive stress is given 100. Okay, so you can cancel out this 20. So 600 d1 square by 4. Now let's find the solution. Square root of the answer is 48. Okay, so diameter d1 is 48.98. Okay, so you can take it approximately 50 millimeter. Okay, now the thickness t, 50 divided by 4 is 12.5. So this is your right answer. Right? If you continue with the dimension found using these tensile equations, it will be 38 and 9.5. So these dimensions are safe in tensile failure, but not safe in compressive failure, as it is clear from the induced compressive stress, right? So this section must works in compression as well as in tensions. That's why we have to increase the dimensions by thumb rule 6 to 8 mm, or simply you have to use these equations to find the same values. Okay, which will come out to be 50 and 50 mm and 12.5. So definitely this is going to survive in tensile failure as well. Okay, this is clear from this lower value. Now let's find the second answer, that is Spigot collar diameter. So Spigot collar diameter. Okay, so let's go for, I'm talking about this diameter. Okay, so you can name it D2. Now because of socket and spigot assembly, there are going to be a compressions, okay, at collar side. So let me draw over here so you can have a clear cut idea, right? This is slot, so this is the area I'm talking about, right? So if you look from the left side, it is simply annular area. Okay, so outside diameter is D2 and inside diameter is D1. So this is the area to which the compressive stress is going to develop. Okay, so let's find it by using equations. Okay, so load P is equal to pi by 4. The outside diameter is called collar diameter D2 and inside diameter is called spigot diameter into compressive stress given. Okay, now here the value is given 60,000. So pi by 4 d2 square. Now d1 square is already we found out, it is 50. Okay, so 50 square, and the permissible stress given is 100. Now try to solve this. 60,000 divided by, okay, so let's simplify this. 600 into 4 divided by pi plus 50 square into d2 square. Okay, so D2 comes out to be around 58 millimeter. Okay, so this is your collar diameter. Okay, now let's find the collar thickness. Okay, so let's find the spigot collar thickness. Okay, now again let's consider same area. So this is spigot having slot over here. Okay, so this is the thickness and this is the rod end. Now because of tensile load and because of action, pushing action of socket end, there are chances that this circular disc may shear from this spigot area, right? So this is the area under the failure. Okay, so considering shear failure of Spigot collar. Okay, now identification of area is very important. So load P is equal to here pi d1 T. Now I'm going to call this thickness, instead of T I'm going to call it F. Okay, so to differentiate from the slot thickness, F into shear stress. Now value is given 60,000. The diameter found out is 50. We want to find out the collar thickness here, and shear stress, let's look at the numerical. What is given? It is given 40. Okay, so 40 is the given. So let's find the collar thickness. Approximately it is 10 millimeter. Okay, so student, try to solve this numerical your own and try to compare your answer with the video's answer. Okay, see you in next video.